All right, evaluate f at x for if it's equal to negative 4x plus 2, so that's essentially your rule, and your input value here is negative 1. So really what this transfers to is that we're saying f at negative 1 is equal to negative 4, oops, I missed the 1 here, negative 4 times negative 1 plus 2. And negative 4 times negative 1, of course, would be 4. So f at negative 1 is going to end up equaling 6 right here. It's confusing language, but really all they're asking you to do is figure out what one variable is given the other variable, so it would be letter D. Number 11 is very similar. This time, though, you're given f at x. So you're going to replace f at x, that's essentially like y, as 29. So 29 equals negative 5x plus 4. And then solving for x, you'll end up getting 25 equals negative 5x. If you divide by negative 5 on both sides, x should equal negative 5. Number 12, it's more of a vocabulary question. The domain of the function f is a set of integers greater than negative 5. So set of integers are all whole numbers and their opposites, so just keep that in mind. Again, that's the vocab. Which of the following values represents elements of the range of f? So given that it's a set of integers greater than negative 5, we need it to be numbers that are greater than negative 5. So this is not greater than negative 5. We can cross that out. This is not greater than negative 5. We can cross that out. We also need it to be integers. So this is not an integer, nor is this an integer. I think what we're left with is just negative 2, 8, 0, and 14. Number 13, the function c at x is equivalent to 600x minus 1500. That represents the cost of a field trip for x students to attend. So if 150 students go on this trip, how much money will that wind up costing? Well, x is the students. It says so right here. So I'm just going to replace, I'm going to do this down here, x with 600. X with 150. So 150 times 600. Let's see, 6 times 15 is 90. And then I have 1, 2, 3 more zeros. So that's $90,000. And you're also taking away the 1,500. That's probably like the cost for buses or something to that effect. Or maybe, oh, you know what, I'm misinterpreting it. The cost for buses maybe gets built in. Maybe they did a fundraiser, and so $1,500 has already been raised, so you can take that off of the cost, the overall cost. So 90,000 minus 1,500. And you might want to do this one out. I know that it might seem easy to do it in your head, but you could easily make a mistake here. So we get $88,500 would be the cost. And then the problem B right here, I'll do out in blue pen. They tell you the cost, so they're telling you what C of X is. So I'm replacing C of X with 82,500. And that's the same thing as it says up here, 600x minus 1,500. And now we just solve for x. So add 1,500 on both sides and dividing by 600. So when we do that, we're left with a problem that really reads 840 divided by 6. And I know that 84 divided by 6 is 14. And we'll have a 0 there. So that'll be 140 students, which makes sense when you think about the trip with 150 students costing a little bit more than the trip with 140 students, right? These numbers are pretty close to each other. They're only off by $6,000, and so the cost of 10 students going is, hey, 600 times 10, right? So that would be 6,000. That number really makes a lot of sense, so 140 students. Number 14, just want to point this out to you. Their y-intercepts are the same, these two lines. The x-intercept of P is like probably negative 2 3/4, I'm just estimating. And then the x-intercept of line Q is negative 4. So line P has a greater x-intercept. And if I was to look at their slopes, looks like we'll pick this point right here for P. We are rising up 3, and we're running over 4. So your rise over run will be 3 over 4. And then for line Q, looks like you rise just 1 and you run 2. And that's the same thing, by the way, as rising 2 and running 4. So Q slope is 2 over 4. P's slope is 3 over 4, so P's got a greater slope than Q. This one right here, which one doesn't represent a function? I'm looking at these x's because I know each input has to have one output. These inputs are all different. These inputs are all different. Those are the same input, and these are all different inputs. So this one would not represent a function because the input 5 has two different outputs.